Hello, we are Assembly Line from STEM High School Best Robotics, and this is our submission for the 2022 Made to Order Competition Simulink Design Award. We start in our system overview. Our main system contains 4 subsystems and a mode switcher allowing us to change between squeaky and field modes. Let's begin in our input block. The input block contains all buttons used for our program. They are grouped by color with joysticks used to move the robot in the green block, general use buttons like battery dropper and mode switcher in the blue block, and buttons used for squeaky mode and compositing in the purple block. The squeaky mode button inputs have 2 important exceptions, 5 up and 5 down, which are used in both squeaky and field modes, and utilize the on-off switch to ensure errors are never made. Let's look at our compositing block. This subsystem assigns a unique value to each button input. The values are then added to a total when the buttons are pressed, ensuring completely unique outputs for every button combination. The outputs are then sent to the squeaky mode subsystem. Our squeaky mode subsystem contains 2 subsystems, arm telescope and IR switcher. We begin in the arm telescope subsystem. In this mode, our arm extends when the left joysticks output a value above 10 and retracts when the value is below -10. Our program has included deadbands in both squeaky and field modes to ensure a proper deadband no matter what mode is active. Next is our IR switcher. It is a modified version of the IR code provided by BEST. We modified it to work with composite inputs and have more functionality, such as improved drive speed and rotational speed adjustments, as requested by our drivers. The image shown is an exploded view of our telescoping arm used to interact with the game field control box. Next, we go to the game field mode. The field mode is made up of 3 blocks, tank drive, arm movement, and battery dropper. Tank drive allows the 2 joysticks to move the wheels directly, arm movement uses inputs from button 5 up and 5 down to raise and lower the arm, and battery dropper uses button 7 left to spin a servo from +90 to -90. In the final block, all button inputs are converted into physical movement on the robot. This includes wheel movement, moving the arm up and down, and extending and retracting the claw. An exception to this is IR data. This data is outputted to the Best Robotics provided serial send block. It is important to note that we were the first team to figure out that there was an error in the serial send and serial receive code provided by Best Robotics. Despite all instructions saying that the BAUD had to be set to 600, it was originally set to 9600 in the provided function. After discovering this, we posted on the Best Robotics forum under the accounts of Great Renown, Forced into Programming, and Irrelevant, informing other teams of this error. Thank you for watching.